Let's talk about the remainder theorem. So before I start this video, if you have not yet watched the video on synthetic division, please go back, watch the video on synthetic division. If you haven't, you're not going to understand what we're doing here. It's going to be confusing and seem weird. So please go watch that. Welcome back to the people who followed instructions and watched that video, or who watched it in order to begin with. Let's talk about the remainder theorem. The remainder theorem is this silly little theorem that just happens to work and make life easier in certain scenarios. So here's what the remainder theorem says. It says if you divide a polynomial by x minus c, the remainder is f of c. I want to break that down. So f of c would be something like f of -2 or f of 2 if you look in this example. Plugging the value -2 in for x in this polynomial, finding out what it comes out to be. Right? And we can do that. We can plug in -2, we can plug in 2, we can do it that way. But the remainder theorem says something kind of fun. It says, hey, if you want to find f of -2 or f of 2, then you would just need, if we're trying to find, let's say, f of -2, then you would need x minus -2. You would need to divide by x plus 2, the polynomial f of x. You would need to divide this polynomial by x plus 2 to find f of -2, and the remainder is f of -2. But hey, synthetic division says as long as you're dividing by x plus c or x minus c, as long as you're dividing by something of this form, you can use synthetic division. So to do this, we're going to find f of -2, we're going to do synthetic division on this polynomial. And it's kind of like we're going to go do a little bit of a loop-de-loo here. Boop. So we're going to start with f of -2. So if we're dividing by x plus 2, then when we go to do synthetic division, we do the opposite sign, right? If this is a positive 2, down here we're doing a -2. But that's interesting, right? Because then it's just putting whatever number you're trying to evaluate f for on the outside. It's just the same number. It's just pretty cool. Anyway, let's take our coefficients. We have all powers of x. -3 is the last. We have 2, -4, and 5. Pull the 2 down. 2 times -2 is -4. -4 minus 4 is -8. -8 times -2 is +16. 5 plus 16 is 21. 21 times -2 is -42. -3 minus 42 is -45. What that means is that f of -2 is equal to -45. And if you're interested, if you're feeling like, Professor Cook, I don't know, that math doesn't seem to check out, you can plug it in, right? You can plug in -2 to this function and see that indeed it does. You can do 2 times -2, I guess, cubed, minus 4 times -2 squared, plus 5 times -2 minus 3. Again, this is just to check your work. This isn't part of the problem. And let's see, we have -8, -16, minus 16, minus 10, minus 3, -32, -42, -45. Crazy, right? So if I'm trying to find f of 2, I can just take 2, put it on the outside here. I can copy all of this, which I guess I could just, there we go. Beautiful. By the way, this negative 45 is the remainder. Anyway, pull the 2 down. 2 times 2 is 4. Negative 4 plus 4 is 0. 0 times 2 is 0. 5 plus 0 is 5. 2 times 5 is 10. Negative 3 plus 10 is positive 7. That's the remainder. That's what f of 2 is. So this is really fun, right? It's kind of handy. Honestly, it's even useful even if you're using a calculator, just because sometimes plugging in negatives is really annoying, especially if it's a really long polynomial and you have to be careful about parentheses, because if they're not in the right spot, then you get the wrong answer in your calculator. It it is a lot easier to do this than plug some of those longer things in. Man, I really should choose a different font on here. This is like P of 1. So that didn't make it any better. That's a 1. Find P of 1. I'm going to choose a better font in the future. So use the remainder theorem to find P of 1. We're going to set up our synthetic division. We're looking to find P of 1. So that 1 is just going to come right here on the outside of our synthetic. We are missing a power of x in here, if you look carefully. So we have 2x to the 4th minus 3x cubed, and there is a missing plus 0x squared for our placeholder, plus 3x minus 8. So we have 2, I'm going to put my negative 8 there first, 2, negative 3, 3. No, 0. Watch me not follow my own rules. Negative 3, 0, 3. And that's because this polynomial really should be 2x to the 4th minus 3x cubed plus 0x squared plus 3x minus 8. All right, pull the 2 down. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. 0 minus 1 is negative 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. 2 times 1 is 2. Negative 8 plus 2 is negative 6. Negative 6. So P of 1 is negative 6. So it's pretty cool, right? It's pretty fun. And then I think that's the only one on this page, right? Yep. We can do some fun stuff here. So let's read this problem. Dividing the polynomial p of x by x minus 6 yields a quotient q of x and a remainder of 3. If q of negative 6 is equal to 1, find p of negative 6 and p of 6. All right, so there's a lot of thinking to do here, and it helps to really take it apart piece by piece. So dividing the polynomial p of x by x minus 6. Okay, if we divide a polynomial by x minus 6, this is then our divisor. And remember what the original setup was. We have a polynomial, which is our dividend. Maybe I'll just call it dividend. We have our dividend, which is p of x. That gets divided by a divisor. In our case, x minus 6. And that's equal to the quotient, and that's q of x, plus the remainder over the divisor. And you know, maybe it would even be better to start there. Let's go ahead and do that. Let's start with filling it out this way. So the divisor, we know, is x minus 6. Okay, we know that. We know that this is the quotient q of x. The remainder is 3. So this guy, remainder, equals 3. I'm going to leave the q of x part alone for a moment. Remainder is, that should be a plus sign. Remainder is 3. The divisor is x minus 6. At this point, you know, I've kind of written down the things I know, and that's what I'm really trying to do here. I'm just trying to almost word vomit the knowledge that I have onto my paper and see where to go. I know I'm trying to find p of negative 6 and p of 6, right? That is what I want, and maybe I'll make a list. We want p of negative 6 and p of 6. We don't know what those polynomials are. We can't just plug negative 6 and 6 in. And the other piece of information we haven't used yet is that q of negative 6 is equal to 1. We haven't used that piece of information yet. So what can we do with this? With a divisor of x minus 6, a remainder of 3, and knowledge that q of negative 6 is equal to 1, what can we do? We look back up here. We know that when we divided the polynomial by x minus 6, the remainder was 3. Oop, oop, oop. What could that mean? What could that mean? Dividing p of x by x minus 6 gives a remainder of 3. If only we had some theorem to find f of c, divide f of x by x minus c. So would that then mean that x minus 6, by dividing by x minus 6, that's telling us that p of 6 is the remainder. P of 6 is 3. The remainder theorem gave us that. Cool. Well, that takes care of one thing altogether. We can cross this guy off the list. The problem then becomes the negative 6. So we got this one from the remainder theorem. Thank you, remainder theorem. P of negative 6. We're going to have to think a little bit. And I'm going to move you. Shrink. Yeah, shrink. You can come over here. We're going to have to think about this q of negative 6 thing, because the best we can do with that information is we can say q of negative 6 could go right here. But if we're doing that, that means we're plugging in x equal to negative 6. Using q of negative 6 there means we're plugging in negative 6 for x. So this would be p of negative 6 divided by -6 minus 6 is equal to q of -6 plus 3 over -6 minus 6. Well, that's interesting because we know q of -6 is 1. We know that. Don't know what p of -6 is. We want that. -6 minus 6 is -12 plus 3 divided by -12. Well, now I have p of -6 divided by -12 is equal to 1 minus 1/4 is essentially what this is. 1 minus 1/4 when it reduces down, which would be 3/4. So to solve for p of -6, which is what I want, this is the whole thing I want right here. I can multiply both sides by -12. So p of -6, after these guys cancel, is equal to -36 divided by 4, which is -9. So p of +6 was 3, p of -6, -9. That's a pretty fun, cute little problem. It takes some thinking, and I know that this might not be something you would have come up with organically. When you're seeing creative problems like this in math, especially ones where it's like, wow, this maybe probably relates back to a theorem, it helps to go to your basics, right? For me, I went back to, oh, okay, where did I see that Q of X notation and P of X notation? Where have I really seen that? And it's when we're talking about how do we write our answer. So I'm going back to that. Anyway, I know this problem took up most of this video, but the remainder theorem is pretty cool, pretty interesting. I hope this video was interesting. And in the next video, we'll talk about the factor theorem, which is very, very closely related to the remainder theorem. It's very interesting. I'll see you in that video. Bye.